galaxies have black holes in the middle. So the purpose of this project is not, okay. Sorry about that. The answer we got was 2.7% of galaxies out of about 224 galaxies have black holes in the middle of them. Now we got this by saying that if the O3, which is oxygen 3, was 8 or more times greater than the oxygen 2, then we considered it to be a spectrum to have a quasar in the center of it.
Okay, then for this experiment, we would need a background. We would need to know what we're talking about. So, first of all, the program we're participating in, the NASA All-Stars 2014, is a summer program that teaches students about physics, objects in space, characteristics about those objects, and technology used to learn these characteristics. For this project, we had to find the percentage of galaxies with quasars. To do this, we used the SDSS, which is the Sloan Digital Sky Survey. We used the SDSS's database to find particular statistics like spectra of over 200 galaxies and quasars. The SDSS is a massive telescope-looking camera located in Apache Point that takes 3D pictures of lots of stars, galaxies, and quasars every night. Dr. Don York was a co-founder of the SDSS along with 2 others. Dr. Don is a professor at the University of Chicago and a teacher at the NASA All-Stars program. This program is based off of quasars that are located in galaxies. Signs of quasars in galaxies include a broad set of emission lines, a big unbalance between the O3 and N2 fluxes, if the O3 fluxes are 8 or more times larger than the N2 fluxes. So this is how we solved it. We found our answer of 2.7% by going through the data of the spectrum. We were looking for if the O3 was 8 or more times greater than the N2. We did this on all of the galaxies in our data that we checked. We then looked at the spectrum. If the H alpha was in the middle of a small peak and N2 was on either side of it, then that galaxy most likely had a quasar. After we figured out how many galaxies have quasars in the middle of them, we divided that number of galaxies in our data, 224 galaxies, by 6, which is how many galaxies had quasars in the middle of them. And then we got 0.026785571. Then we multiplied that by 100 and got 2.6785571. Then we rounded and we got 2.7%.
Our team has found that there were many more narrow lines and broad lines in our data. The spectrum we looked at had a range of 3 narrow lines, 2 broad lines to 1 absorption line. The trend for our galaxy spectrum was the spectrum goes up a little, then goes across as seen as the first spectrum in the results. The spectrum had a couple narrow lines. The quasar spectrum goes from high to low, then forms a plateau with little broad lines. When our group was working on finding the answer, we talked with others about how the broad lines were very rare and how we classified narrow lines, broad lines, and absorption lines. During our research part of the project, a member of our group did not know he had to note the line sigmas of all the fluxes, so we had to start over and looked at all of the line sigmas. A line sigma is the width of a flux line. One of the limitations of our research is that we could only use the STS database, and the STS database gathers information from one part of the spectrum, and we needed to look at different parts of the spectrum to locate other quasars. And just the picture below is the type of emission lines, which are absorption, narrow, and broad.
Okay, then here are the people we would like to thank. We would like to... fine, sorry. The results that we found are these. Okay, we found these different galaxies, and we found a quasar, well, multiple quasars, and then we found some galaxies with quasars in the middle, and then these are the spectrum of. This is a spectrum of the galaxy without a quasar. As you can see, the lines don't really go up; they just pretty much dip down, except for this part up here where it rose up. Sorry. And then here's a spectrum of a quasar, the thing that we were looking at inside a galaxy. It kind of went down. Here it peaked up a bit, made a broad emission line. Here it's wide and it's a peak up, and then it kind of went down more. Next, here's a galaxy spectrum with a quasar. This is also a broad line because, here's some peaks, and then here's one peak. It has an H alpha element in the middle with 2 nitrogen 2s on the side. That is one of the criterions for a quasar that was in our methods. Okay. Here are the people that we would like to thank.
We would like to thank the teachers and the staff that participated in this program. They were extremely helpful throughout the program. And then these are the people that we included. Professor Donald G. York, Mr. Thomas Mackey, Mrs. I'm sorry if I get your name wrong, please correct me. Mrs. Sabrina Wetzel, Mr. Isaac Ravivens, Mr. Mark Casey, Mrs. Emin Sarhan, Mrs. Jackie Barge, for putting all the tools on the vlogs and all the repeaters that helped us.
And we would like to thank Mr. Mitch, Mr. Russ, and Mr. Terry for helping us fix our computers.
Any questions?
What was your plate number?
R2030. 2000. Any other questions? Jacob!
How many different galaxies or quasars did you guys observe?
We went through about 16 to 50. I would say a good amount.